This is the importance and significance of nuclear fusion-fission hybrid reactor. A nuclear fusion-fission hybrid reactor is important because it can generate a large amount of energy more efficiently than conventional reactors. It is also significant because it can reduce long-life radioactive waste, which help lessen environmental impact. In addition, this reactor improve fuel utilization by making better use of resources such as uranium and thorium. Another advantage is enhanced safety compared to traditional nuclear reactor. Overall, it is considered a promising technology for clean, sustainable, and low carbon energy in the future.
Now we are going to talk about the challenges and solutions of nuclear fusion in fission hybrid reactor. First, one of the main challenges is plasma instability. In nuclear fusion, the fuel becomes plasma, which is extremely hot and hard to control. The problem is the plasma can easily become unstable and stop the reaction. To solve this, scientists use magnetic systems like tokamak. This use strong magnetic fields to hold and control the plasma so the reaction can continue safely. Next is material damage. The reactor produces high energy particles that hits the walls and slowly damage them. This can make the reactor weaker over time. To solve this, scientists use very strong heat and radiation-resistant materials like tungsten. They also design parts that can be replaced when damaged. The third challenge is the fuel, especially tritium. Tritium is a rare and radioactive, so it is not easy to get or handle. The solution is to produce tritium inside the reactor using lithium. This is called a breeding blanket, so the reactor can actually make its own fuel, which makes it more efficient. Now, I will show some real-world examples related to fusion and hybrid reactor technology. First, the ITER project in France. This is one of the biggest fusion projects in the world. It uses a tokamak system to study how fusion can be used to generate energy in the future. Next is research from the Lawrence Livermore National Laboratory in United States. They achieved a major breakthrough where fusion produced more energy than it's used using powerful lasers. Lastly, it is the China Fusion Engineering Test Reactor in China. This is a future project aimed at producing electricity from fusion on a larger scale. So all these examples show that fusion and hybrid technologies are already being developed and could become important energy sources in the future.
Next, I will continue with recent studies. One of the most significant recent development in this field is the progress of the ITER project. ITER is an international collaboration that aims to demonstrate the feasibility of nuclear fusion as a large-scale and sustainable energy source. Although it's mainly focused on pure fusion, the technologies being developed, such as plasma confinement and superconducting magnets, are highly relevant to fusion-fission hybrid reactors. These advancements help improve the overall efficiency and feasibility of hybrid system in the future. Another important area of recent research is the development of fusion-driven subcritical reactors. In this approach, fusion reaction generate high-energy neutrons that drive a fission process in a subcritical core. This design significantly enhances safety because the fission reaction cannot continue without the fusion source. As a result, the risk of uncontrolled chain reaction is greatly reduced, making hybrid reactors a safer alternative compared to traditional nuclear reactors. In addition, many studies are focused on advanced materials and computational apa anjing? Next, I will move on to application in real life. One of the main real-life applications of nuclear fusion and fission hybrid reactors is large-scale electricity generation. These reactors are designed to combine the high energy output of fusion with the stability of fission, allowing them to produce a continuous and reliable supply of power. Unlike fossil fuels, this method generates significantly lower carbon emission, making it a cleaner alternative for meeting global energy demands. As energy consumption continues to increase, hybrid reactors have the potential to support sustainable electricity production on a long-term basis. Another important application is nuclear waste reduction. Conventional nuclear fission reactors produce long-life radioactive waste that pose environmental and safety challenge. However, hybrid reactors can utilize high-energy neutrons from fusion reaction to break down this waste material into shorter life and less harmful isotopes. This process, known as transmutation, helps reduce both the volume and toxicity of nuclear waste, making nuclear energy more efficient and environmentally friendly. In addition, hybrid reactors can be used for hydrogen production. Hydrogen is considered one of the cleanest energy carriers, especially for transportation and industrial sectors. Hybrid reactors are capable of producing extremely high temperature required for efficient hydrogen production process, such as thermochemical methods. This supports the development of hydrogen-based energy system and reduce reliance on fossil fuels, contributing to a more sustainable and low-carbon future.
Hi everyone. Today I will talk about potential career related to nuclear fusion. One important career is fusion physics. Fusion physics study plasma and nuclear reaction to improve fusion reactors. Another career is nuclear engineering, where engineers design and develop reactor system and safety technology. Besides that, mechanical and electrical engineers are also needed to build cooling system, magnet, and power system to fusion facilities. Software engineers and AI specialists help by creating computer, simulation, and monitoring system to control reactor performance. They are also career outside science and engineering. For example, project manager coordinate fusion projects, while science communicator explain fusion technology to the public. Environmental scientists also study how fusion energy can reduce pollution and support clean energy development. In conclusion, nuclear fusion offers many career opportunities in science, engineering, technology, and business. As fusion technology continues to develop, this career may become more important in the future. Next, I will explain the purpose and specific skill needed for careers related to nuclear fusion. The main purpose of nuclear fusion careers is to help develop clean and sustainable energy for the future. Fusion energy can reduce pollution and decrease dependence on fossil fuels such as coal and oil. It can also improve energy security and support scientific and technological advancement around the world. To work in this field, several important skills are needed. First, technical skills such as knowledge in physics, mathematics, engineering, and computer programming are very important. Workers also need problem solving and data analysis skills to operate and improve fusion technology. Besides technical skills, soft skills are also necessary. These include teamwork, communication, critical thinking, creativity, and time management. Since fusion projects involve many experts working together, good cooperation skills are very important. Students who are interested in field usually study physics, nuclear engineering, mechanical engineering, electrical engineering, or computer science. In conclusion, nuclear fission career play an important role in creating clean energy for the future. Both technical and soft skills are needed to succeed in this growing field.
So, for continuous self-development part, it is extremely important in the field of nuclear fusion and fission-fusion hybrid reactors because this technology is still in the research and development stage. Unlike traditional energy systems, fusion technology is not yet fully commercialized, which means new discoveries and improvements are happening all the time. Because of this, professionals such as engineers and scientists must constantly update their knowledge and skills. This can be done through reading scientific journals, attending workshops, and participating in research projects. For example, organizations like IETER involve experts from different countries and they continuously learn from each other to improve reactor design and efficiency. In addition, self-development also includes learning new technical skills such as simulation software, data analysis, and programming. These skills are important to model nuclear reactions and improve reactor safety. Without continuous learning, professionals may fall behind in such a fast-changing field. Therefore, self-development is not optional, but necessary to contribute to future energy innovation. Lastly, in conclusion, fission-fusion hybrid reactors represent a promising solution to future global energy challenges. They combine the advantages of both nuclear fission and fusion, offering high energy output with reduced environmental impact. Although there are still challenges such as high costs, complex technology, and extreme operating conditions, ongoing research is making steady progress. Recent advancements, including experiments conducted at Lawrence Livermore National Laboratory, show that fusion energy is becoming more achievable. Looking ahead, hybrid reactors could play a major role in providing clean, sustainable, and reliable energy for growing populations. This is especially important as the world moves away from fossil fuels to reduce climate change. However, achieving this goal requires not only technological advancement but also skilled professionals who are committed to continuous learning and innovation. Overall, with continued research and development, fission-fusion hybrid reactors have the potential to transform the global energy landscape in the future.